This is the first test review worksheet for the Trig Identity unit. It's pages 61 to 63. I have a few minutes left until lunch, so I'm going to see how far I get, and then maybe this video will be in 2 parts. We'll see what happens time-wise. All right, 1 over cotangent is the same thing as tangent of theta. Sine over cosine is tangent of theta. And you can use your formula sheet, ta-da, if you want, or if you have them memorized by this point. Cosine squared plus sine squared equals 1. 1 over cosecant is sine. The complement of tangent is cotangent. And F got switched down here. Cotangent squared plus 1 is cosecant squared. Oops, it's an X. 1 plus something is secant squared. That's tangent squared. Cosine over sine is cotangent. The reciprocal of secant is cosine.
Good morning, everyone. Please.
Sorry, there's an announcement.
The fire alarm is offline, so if you hear the fire alarm, please disregard.
Okay, so then the complement of cosecant is secant.
So please disregard any fire alarm that you hear.
And then these last 2 identities more are about the symmetry. So if you think of the cosine graph, the negative angle is equal to the positive angle because it's an even function. And since sine is an odd function, it's equal to the opposite sign. Okay, number 2, let's do some identities to simplify. Of course, I don't have enough space there. So let's do A. I'm going to change cotangent to cosine over sine. And then times sine, but I put over 1 to show that those line up, and our answer is cosine of theta. For B, 1 minus cosine squared, if I look at the manipulation of my Pythagorean identity, if I subtract cosine squared over, that's sine squared times cosecant. Well, cosecant is 1 over sine. So 2 sines over 1 sine divide and leave me with 1 left. Another way you can think of it is as sine times sine in the numerator, 1 of them in the denominator, sorry. So those eliminate. And then C, secant squared minus 1. I'm going to look at my Pythagorean identities again. Secant squared minus 1 is tangent squared. And then I'm going to write tangent as sine divided by cosine, but both squared. These divide, and we are left with sine squared theta. Multiply. These are conjugates. So I know the middle term is going to eliminate. Oh, they all are conjugates. That's okay. Let's do cotangent times cotangent. Cotangent times negative cosecant. Cosecant times cotangent. And then cosecant times negative cosecant is negative cosecant squared. So because they're conjugates, these middle terms add to 0 and left with cotangent squared minus cosecant squared. Oops. And we can simplify that more because we have this identity. So let me write that here. So cosecant squared equals 1 plus cotangent squared. So if I want to have cotangent squared minus cosecant squared, I'm going to subtract this over to this side. And then subtract the 1 to the left. So cotangent squared minus cosecant squared equals -1. Okay, so for number 2, I know since they are conjugate terms, when I multiply the outside and the inside, they're going to add to 0. So I'm just going to do cosecant squared times cosecant squared, and 1 times -1. And then if we look at our identities again, cosecant squared, if I subtract 1 to the left, equals cotangent squared. And now for C, 3 times 3 is 9, minus 3 times 3 is 9, sine squared. I'm going to factor out a 9. And then 1 minus sine squared from this identity is cosine squared. So we get 9 cosine squared theta. Factor and simplify. Okay. In A, they share one sine that I will factor out, and I'm left with sine squared plus cosine squared. If you want, when you're factoring, you can think of that as dividing by the term you are factoring out. Then sine squared plus cosine squared is 1, so we get sine theta as our answer. B, that's the difference of two squares, cosine to the fourth minus, sine to the fourth minus cosine to the fourth. If you want, you can think of that as x to the fourth minus y to the fourth. So that factors to x squared minus y squared, x squared plus y squared. Conjugates when you have the difference of two squares. So let me put back in sine squared minus cosine squared, sine squared plus cosine squared. Sine squared plus cosine squared is 1. And then sine squared minus cosine squared is nothing. We're just going to leave that as our answer. For C, I notice we've got tangent squared minus 2 tangent minus 3. So it's like a normal quadratic factoring, except with tangent. So what multiplies to -3 that adds to -2? It's going to be -3 and +1. And we had tangent. And that is our factoring for C. D is similar. I'm not going to use x because there's already an x here. So this is like w to the fourth minus 2w plus squared plus 1. So what multiplies to 1 that adds to -1 is -1 and -1. But because this is to the fourth and squared, I'm going to factor to sine squared, not just plain sine. And then these are the same, so this is sine squared x minus 1 all squared. You could leave this, or we could do subtract this one, subtract that cosine, and make it negative cosine squared. I would probably leave it like that. Okay, let's keep going. E, I'm going to factor out a cosecant squared. And then 1 minus cosine squared is sine squared. Oh, cosecant is 1 over sine. This is 1. And what's F? Sine plus cotangent cosine. I think the only thing I can start with is making cotangent into cosine over sine. And then combining this fraction, that's cosine squared divided by sine. Then I'm going to get a common denominator to add them together. So my numerator becomes sine squared plus cosine squared, which is 1 over sine. That is cosecant of theta. You know, you can always use a pickup line. I'm sine squared and you're cosine squared, and together we make 1. Haha. That's a good joke. That way you know at least if the person you're using that on is smart and knows some pre-cal. All right, rewrite sine y over cosine y plus 1 so it is not a fraction. So to simplify this fraction, I'm going to multiply by the conjugate of the denominator. So the numerator becomes sine of y times cosine of y minus 1 all over. And then remember, when we multiply conjugates, we're going to get cosine squared from the first, and then 1 times negative 1 minus 1. So then cosine squared minus 1 from my Pythagorean identity is negative sine squared. So then sine, and one of those, so we're left with cosine y minus 1 over negative sine y. Well, it's still a fraction. So instead of divided by sine, of course I ran out of paper again, I'm going to make that multiply by the reciprocal of the denominator. Then I know that 1 over sine is cosecant, but negative. And is there anything else I can do to that? I mean, I guess I could distribute the cosecant. So it's negative cosecant cosine plus cosecant. Multiply it like that. Okay, number 5 is not a fraction anymore. Number 6, prove the identities. I'm going to work on the left, not the right. To get these fractions combined, I'm going to use a common denominator. So this right fraction needs a cosine over cosine. So we're going to get 1 minus cosine squared divided by the denominator. 1 minus cosine squared is sine squared from our Pythagorean identity. 2 sines in the top. One of them will eliminate with the bottom, so we're left with sine x over cosine x. And I should have used better math vocabulary. 2 sine squared in the numerator eliminates with one of the sines in the denominator, leaving us with a sine in the numerator. And then sine divided by cosine is tangent of x, and we got our answer. So now for B, I'm not going to make a common denominator. I'm going to simplify. I know that, well, this is secant times, so 1 over sine is cosecant minus tangent. That doesn't really get me anywhere. Scratch that. Start again. Let's make a common denominator. So my common denominator is going to be sine times cosine. So this first term is missing a cosine. My second term is missing a sine. Oh yeah, that would have been a better strategy to start with, Miss Weiss, but that's okay. So secant times cosine. Well, secant is 1 over cosine. So this first part is a 1. So we get 1 minus sine squared all over sine cosine. Well, 1 minus sine squared is cosine squared for the numerator. And then 2 cosines in the numerator, one of them will eliminate with the denominator. So we are left with cosine divided by sine, which is cotangent, and that is what we needed. Yay. All right, last page, and I'm gonna hopefully make it before the bell. secant squared plus cosecant squared equals secant squared times cosecant squared. Let's see there. I'm going to, on the left, change that to 1 over cosine squared plus 1 over sine squared. Oh, it's thetas now. Then I'm going to get a common denominator of cosine squared times sine squared. So this first one is missing a sine squared. This one's missing a cosine squared. Sine squared plus cosine squared is 1. Now that I have one fraction, I can think of this as 1 over cosine squared times 1 over sine squared. 1 over cosine is secant. 1 over sine is cosine. No, it's not. It's cosecant, sorry. And that is what we needed. Secant times cosecant. Squared, both squared. All right, D, we have sine tangent equal to secant minus cosine. I think I want to simplify the right side. The secant is 1 over cosine. And then if I get a common denominator, that's 1 minus cosine squared over cosine, which is sine squared over cosine. And then I'm going to write that instead of sine squared as sine sine over cosine, because this is tangent, that is sine, and we get our answer. That was exciting. Okay, and E. I think I'm going to start on the right side again. 1 over secant times 1 over cosecant. That is cosine times sine. How am I going to get that to adding in the denominator? I don't know. Okay, so let's start on the left. Scratch that, try again. 1 over tangent plus cotangent. Oh, I'm gonna multiply by the conjugate of the denominator. So that on numerator and denominator. So tangent minus cotangent. So that leaves the numerator alone. The denominator then is tangent squared minus cotangent squared. Does that get me anywhere? Well, that's not an identity, so no. So let's see, what else can I try? One second while I get some extra paper here because I'm running out of space. Oh, I know what I'm going to do. When all else fails, change everything to sine and cosine and try to simplify. I can't find my, here we go. Okay, so that's 1 over sine over cosine plus cosine over sine for the left side. So then to make a common denominator in the denominator, I want cosine times sine. So that's going to give me sine squared on the left, cosine squared on the right. And this is all in the denominator. So now that is 1 over cosine times sine. So instead of a fraction and then a fraction, I'm going to multiply by the reciprocal of the denominator. And that's cosine over times sine. Oh, and I want to get to secant, cosecant. So I know that cosine is 1 over secant, and sine is 1 over is over cosecant. And if I make that one big fraction, whew, I get the answer. Third time was a charm on that one. Okay, solving. I'm going to isolate the sign by adding the 1 and then the 2. Where are my special triangles? I'll just draw them again. So then what is opposite of the 1 is pi over 6. But I need every answer from 0 to 2 pi. So sine is also positive in the second quadrant, which gives me 5 pi over 6. For b, I'm going to factor out a sine x. Set each factor equal to 0. That's more scrap paper. This one is sine x equals -1. So I'm looking for, in my special quadrantal angles, over 1 up 0. Sine is the y value. So where is the y value 0? And that's at 0 and pi. And we include 0 in our answer, not 2 pi. And then where is the y value -1? That's at 3 pi over 2. I'm going to make sine squared into 1 minus cosine squared. Distribute the 2. I'm going to move everything to the right side because I like the squared to be positive. So that gives me 0 equals 2 cosine squared x plus cosine x. And then I can factor out a cosine. Set each factor equal to 0. And that gives me, here, if I isolate the cosine, subtract 1, divide by 2. So cosine is the x-coordinate. So when is the x-coordinate 0? Is at pi over 2 and 3 pi over 2. And this one, I want to know adjacent over hypotenuse. So what is adjacent is pi over 3. But I need the quadrants where cosine is negative, and that's up here and down here. So that's 2 pi over 3 and 4 pi over 3. Oops, sorry, 2 pi over 3 and 4 pi over 3. Because this is 3 pi over 3. So a little less and a little more. So for D, I'm going to isolate the tangent. I'm going to add the 1 over and divide by root 3. So this is opposite over adjacent. So that's going to give me the pi over 3 angle. But tangent is also positive here in the third quadrant. So that is 4 pi over 3. And last but not least, and I'm going to do it with a few minutes to spare, I'm going to divide by 2. Subtract 1. So positive 1/2 minus 1 is negative 1/2. We already have these answers. That is 2 pi over 3 and 4 pi over 3.